ways of explaining that and recognizing that. We had mapping diagrams, graphs, equations. We had all kinds of stuff, right? But at the end of the day, if you ended up repeating any of your inputs or repeating any of your x values, then it didn't work. Awesome. Today, what we're going to do is function notation. So how to write an equation if it's a function. Up until this point, we've always written things like this. Y equals 2x plus 3. That's been how we've written all of our equations. That's fantastic. That represents anything we work with, and that's fine. However, if something is a function, so if y isn't just some special relation or equation, it's actually a function, we have a different way of writing it. Instead of writing it as y equals, we would write the exact same equation as f bracket x. And then everything else will stay the same. These two things mean the same thing. The second one, by saying f of x, just means it's a function. That's all it means. Not hard, right? A lot of people like to remember it that y and f of x mean the exact same thing. This does not mean f times x. This means function of x. Okay, this equation is a function of x. Realistically, you can just flip these two things back and forth anytime you want, and you'll be fine. So if you just remember y means f of x, you'll be set. How this looks for questions. It helps us kind of shorthand rate things. Right? So we're going to skip down a little bit because we don't really do map notation. We're going to skip to here. The way that we can make things a little quicker is they can tell you what x is without having to write when x equals 5, right? And we've seen that before, like it's a little sentence like x equals this. Instead of saying that, they can write things like this. So it should have been f of x. They've changed it to f of 5. That means they're telling you x equals 5. How that would look on a question. They've given you an equation right here. We're going to do this one. Don't worry about the other two. They said f of x equals 2x plus 3. Now they want to know what f of 5 equals. So you go to your equation, you change x to be 5, and you also change x to be 5 in the question. Because now you know x equals 5. When you do that, you should be left with something that you can put right into your calculator. You put that in your calculator, it equals 13. That means when you have an input of 5, you get an output of 13. That's all we're doing. It's just a fancy way of being able to change x's and y's. We're going to skip a little further down to examples so we can actually do them. Perfect. This is the example I want. To help it all kind of come together. So it says consider the function, and they give you two functions. They give you f of x, so that would be function f, and g of x. We call that function g. Then it says evaluate. Evaluate means calculate. All right. The first one says f of 3. You'll notice they've changed x to be 3. This thing is saying x equals 3. Right? It's just a shorter, quicker way of writing it. So what you need to do is go to your function f and change x to be 3. So we go to function f and we change all of our x's to be 3. Remember, when we change things, we use brackets. So it should look something like that once you substitute x for 3. X is our input value. That means we need to calculate what our output value is. you only calculate this side. When you put that in your calculator, so bracket 3, bracket squared plus 5, you're going to get 14. So I would say function f, so f of x at 3 would equal 14. On a graph, your input would be your x value, which would be 3. Your output would be what you calculated, which is 14. Input, output. This is another way of writing it out. Awesome. For b, we can do the same thing, except this time they want g, right? They didn't use function f, they used function g. So we got to look up here and look at function g and change x to be 1. We're going to do the same thing. So we're going to go g1 equals 4 minus 1. You're going to calculate that. With g of 1 equals 3. Now do your answer. Input would be 1, output would be 3. That's function notation. Not that crazy, right? Awesome. Try C and D on your own. We'll do E together. Okay, so give it a shot. Try C. See if you can make the proper substitution. Be very careful with your brackets.
Gotta keep doing the bring silver home.
No worries. Alright, so if we look at C, this means function f, x equals -2. So you would go to function f, and you would change x to be -2. Remember, we use brackets, and in your calculator, that's very important that you do use brackets, because if you don't, your calculator actually makes an error when it calculates. So I don't put the brackets there just because, right? Those brackets are a good habit to get into. And in your calculator, you should also put brackets like that. When you calculate this with brackets, and the square is outside the brackets, you should get an answer of f of -2 equals 9. If you didn't use brackets, you would have got 1 as your answer. So make sure you're using brackets in your calculator. Awesome. If you go to D, D says g x equals -2. So you go to function g, and you would change x to be -2. When you do that, you end up with 4 minus -2. When you're minusing a negative, it turns into a positive. This thing would end up being g of -2 equals 6. Just be very careful with your double negatives and your brackets and all that jazz. Awesome. E. E's a little bit different. So E's got 2 here. So what they want you to do is they want you to go to function f, change x to be 0, and get an output value. Then they want you to go to function g, change x to be 0, get your output value. And then they want you to subtract the output values from each other. So if you look at f of 0, we'll do that one first. F of 0 would equal 0 squared plus 5. That means f of 0 equals 5. If you calculate g of 0, you have g of 0, you get 4 minus 0, g of 0 equals 4. Now what the question wanted you to do was take those two answers and subtract them from each other. So if f0 is 5 and g of 0 is 4, they're asking you what's 5 minus 4. And that's the actual question. So we would go 5 minus 4 equals 1. That means function f of 0 minus function g of 0 would equal 5 minus 4, which equals 1. Beautiful. That's function notation. It gets a little bit trickier. We're going to change things a little bit. Just see a couple other ways they can write things out. But for the main part, that's it. If you can understand inputs, outputs, you'll be good. Inside the bracket is your input. Whatever you calculate outside the bracket, that's your output. That's your y value. We're going to scroll down, look at another question here. It says consider the function f defined by, then they give you the function. And then they put this part right here. Actually, this is a good tuple. They put comma xer. They're just telling you what x can be for the question. When they say xer like that, that means x could be an element of the real numbers. So for this function, x can be any number. That's what they're just telling you. It makes no difference on your question. It's just a mathematical proper way to state a question. All right? Realistically, you could do this. Do the question the exact same. Okay, so it really doesn't have an effect on the question. When you see that, don't get freaked out by it. Awesome. Then it says determine. We got a bunch of questions here. We'll start with A. That says f of negative 3. Notice that the number on the inside has changed. That means they're saying x equals negative 3. You have an input of negative 3. So you go to your function and you change it. You're going to have 5 bracket negative 3 bracket cubed minus 2 bracket negative 3. Use the brackets, okay? They're going to be helpful. Throw that in your calculator. Pardon? What'd you get? Negative 129? Yeah, that sounds about right to me. It's going to be a big number. Because negative 3 cubed is going to be negative 27, and then times 5, and then you're going to add 6 to it. So I'm with you. Negative 129? Yeah. Sounds right to me. Anybody agree? Anybody disagree? Anybody do the question other than Hunter? Yeah, we got a couple nods in the crowd. Negative 129. You like that answer? Good. All right. Remember, this is like an input-output situation, right? So the number inside negative 3 is my input or my x value. Negative 129 would be my y value or my output value. Awesome. Let's look at B. It says the value of f when x equals negative 2. That is function notation in Word. Oh, sorry, x equals 2. I said negative 2, didn't I? Yeah. That's just function notation in words. What they're saying is f at 2. It's the same thing. Okay? They just use words to describe it. We're going to go to our thing. We're going to change x to be 2. That means f of 2 equals 5, 2 cubed minus 2 times 2. That one's going to be 36, I think. That means f of 2, or the function f when x equals 2, is equal to 36. for C, we don't do image. Like, I don't talk about image. If you do ever see it though, and you're just curious what that means, this would be f of 7. The image of 7 under f. They're telling you x equals 7. We don't do that stuff. Just don't need to. Down here for E. E is a little unique. We haven't seen it before. What we usually see for input values is numbers. Right? We're always used to being like x equals 2 or x equals -3. What we're not used to seeing is when they use input values as letters. That's what they've done here. So instead of saying f equals a number, they're going to say f of a. All you do is you take a and you make x a. So for us, it would look like this. F of a equals 5 times a squared or cubed minus 2 times a. That would be your answer. You just go change x for the letter a. That's a little bit different. Right? We're just not used to seeing that, and it feels almost a little uncomfortable to leave your answer like that. Right? But that is all it is. It's an expression for when x equals a. Awesome. The last one's probably the hardest one. Pretty normal, right? They're saying that x equals 2x. Right? That's what this means. So you should go into your equation and make all your x's equal to x. When you do that, use brackets. I'm going to show you how it works. So we're going to go up to our equation. We're going to change all of our x's to be 2x. That means I have 5 bracket 2x bracket cubed minus 5 times 2x.
It's minus 2.
Thank you. For which one?
Put X on my calculator.
So that at this stage, because you're here right now, right? Okay, this you can't put in your calculator because it's got letters in it, and your calculator, like, it does have a value for x in its calculator. So if you put it in, it'll give you an answer. But you don't actually want to calculate that because your calculator might say x equals 2, but like Alfie's calculator might say x equals 100, right? And then like Noah's calculator might say x equals 1. So you all have different values of x in your calculator. So you're not actually going to get a number, you're just going to get an expression. So it's going to be like an equation like this. Okay? With this, we're not quite done yet. The reason we're not quite done yet is because you can do some simplifying. So we substituted properly, but now we need to follow some of our rules that we learned in previous units. The first rule we need to remember is the exponent rule. Okay, so that exponent needs to come into the bracket. When it comes into the brackets, it's going to become f of 2x equals 5, and then bracket 2 to the power of 3 equals 8. And then x to the power of 3. Everything else stays the same. Right, so I brought the exponent in, and I actually calculated 2 to the power of 3. Yep.
You have to do that for the. Oh, no, never mind.
Yeah, because for this one there was nothing there, right? You could technically just write it as like without the brackets. Like bring it in and then the brackets go in. Alright, for f, there's still one more thing we can do. So we simplified the exponents, now we need to simplify any coefficients that we have. Remember that when you had two coefficients beside each other, like that, or like this, you could actually multiply them together. So for this equation, we would finish it off with f of 2x equals 5 times 8 is 40 x cubed. Minus 2 times 2 is 4. So I get 40x cubed minus 4x. That would be your simplified expression. That's as hard as it gets, I think. It's a little abstract. There's some calculation there. There's some recall from previous units. And that's a hard question. Yeah, for sure. Awesome. That's example 3. I'll do it with you because it's kind of crazy. It's going to be the same thing as what we just did, but now the substitution is going to be even harder. So instead of it being just a monomial, it's going to be a binomial, which, if we remember, makes our multiplication a little bit of a pain in the butt. So if you look at this question, they have p of x equals this. Determine a simplified expression for p of x minus 3. This means that x needs to change to be x minus 3. So I go back to my equation, and I'm going to substitute x with x minus 3. It's going to be a lot. So I have p x minus 3 equals 4 x minus 3 squared minus 6 x minus 3 plus 1. That's what my substitution would look like. Fantastic. If you do the substitution, that's great. That's like a start. But then we need to simplify our expression. Okay, to simplify our expression, we're going to have to actually expand this all and then collect like terms. Expanding this is going to be a little hard, right? That's unit 2, polynomials. The expansions that we have to do start right here. Right? This is a binomial squared. So that doesn't mean we can bring the squared in. This means we have x minus 3 times x minus 3. So we actually have to do an area diagram. I'm just going to run out of space, so I'm going to do my area diagram right here. I need to do x minus 3 times x minus 3. Remember that stuff? Yeah. So this would turn into x squared negative 3x negative 3x and positive 9. So up here, that means I can expand this wow. Really not liking me right now. To be x squared minus 6x plus 9. Everything else stayed the same for now. Minus 6, x minus 3, plus 1. So all I did was deal with that exponent. Right? I took that binomial squared, I expanded it. The second thing I try to simplify is any multiplication that needs to happen. So we do have some coefficients here that need to be dealt with. Right? This guy right here needs to be multiplied in. And this guy right here needs to be multiplied in. So we distribute our coefficients into the brackets. That's going to give me p of x minus 3 equals 4x squared minus 24x 9, 18, 27, 36 plus 36. Minus 6x plus 18, because remember the negative comes in with the 6, and plus 1. That's what my equation would look like after I've done all of my expanding. I did my exponent expanding, then I did my coefficient expanding. After we expand, we collect any like terms we might have. Looking at this, we have some like terms, right? We start with our x squared. There's only one x squared, it's 4x squared. So my final answer is going to be right over here. I have 4x squared. My next thing would be my x's need to be combined. So I have negative 24x minus 6x would be negative 30x. And then I have plus 36, plus 18, plus 1. You're going to combine all of those. You're going to get 55. Your final answer would be this equation here. P x minus 3 equals 4x squared minus 30x plus 55. Beautiful. That's as hard as it gets. Okay, that's pretty extreme. If that was on a test, I would call that probably the hardest question on your test. If that was on your unit test. Just for the record. Awesome. That's function notation when they give you an input, right? They've been giving you an x value. They can also use function notation to give you y values or output values. It just changes slightly how they write it. So if you look at classic example number 4, they give you a function, so consider the function f of x equals 10x minus 3. Remember the XCR doesn't really affect us, that just says x can be any number. Question A, determine the value of x if f of x equals 47. This does not mean x equals 47. They're saying f of x equals 47. Remember, f of x and y are the same thing. So what they're really saying is y equals 47. They're giving you an output value. That's what it looks like when they give you an output value. Your job is to find the input value. To find the input value, you're going to go to this question. You're going to change f of x to be 47. The whole thing's going to change. So you end up with this. Oh, Mr. Need more space. I don't want to be able to show you all the steps. So, there we go. So you're going to go to this equation. You're going to change f of x to be 47. So you now have this. You have 47 equals 10x minus 3. That's how you substitute an output value in. From there, you figure out what your input is, or what your x value is. You're going to isolate x, right? That's the terminology we use. We get x by itself. We get x by itself by doing reverse BEDMAS. So we're going to move any subtractions we can away from x. We have a subtract 3. We can move a subtract 3 by adding 3 to both sides. When you add 3 to both sides, you end up with 50 on the left side equals 10x, and then the 3's will cancel out. You then move any additions that you have. There are no additions. You then move any multiplications that you might have. We do have a multiplication here. Remember when you have two letters or two numbers or two things written side by side, a letter and a number, that means multiplication. So what we need to do is move that 10 away from the x by dividing by 10. When we divide by 10, 5 divided by 10 is 5. 10 divided by 10 cancels out, and all you have is x. That means when f of x equals 47, x equals 5. Input would be 5, output would be 47. Okay, so they use function notation to also give you outputs. They just flip it, right? That's the only way it changes. So if you look at B, if we were to try that, it says solve the equation f of x equals negative 23. They're telling you y equals negative 23. If they give you y, you're looking for x. The way we do that is by making the substitution and then isolating. So we're going to go up to this equation. We're going to change f of x to be negative 23. Everything else stays the same. Your job is to get x by itself or to isolate x. We do that by moving this subtraction first. We're going to add 3 to both sides. That leaves you with negative 20 equals 10x. And then we divide by 10. When you divide by 10, you get your final answer of negative 2 equals x. Right? Input value would be negative 2. Output value would give you negative 23. Beautiful. Should we do this? Yeah, let's do this last one. Actually, you try it. So the first one's giving you an x value, the second one's giving you a y value. The third one, yeah, try to solve the third one. Just give me a y value as well. Okay, let's give it a shot. You should be able to do it. So this would be like a pretty standard test question. They give you an equation, then they ask you to do a couple things with it. It says consider the function f of x equals x squared minus 5. Again, the XER doesn't mean anything to your question. It just means that x can be any number. Your answer could be anything. For A, it says evaluate f of 4. This, when they change the number on the inside, is telling you x equals 4. Right? They're giving you an input value when they write it like that. You go to your equation, you change all your x's to be 4. Like that. You put it in your calculator, and you should get 11. Awesome. B is the other situation. So instead of them giving you an input, they give you an output. When they write it like this, they're saying that y equals 4. That means you can go up to this equation and change f of x to be 4. So you have 4 equals x squared minus 5. Your job at that point is to try to get x by itself. You're going to add 5 to both sides. Add 5. That gives you 9 equals x squared. And then you have to square root. Right? That's how you get rid of that square. So you square root both sides. When you square root both sides, that gives you 3 equals x. The last one is a little tricky, just because the numbers aren't nice. That's all it really changes. They also changed x to be t, which really doesn't make a difference. It's just you should change your x to be t as well. So when you do this question, they say f of t equals 75. That means I change the front number to actually be 75. Then I have t squared minus 5, like that. We need to get t by itself, so we need to move that 5. We add 5 to both sides. That gives me 80 equals t squared. Your last step is to square root both sides. Oh boy. When I square root both sides, I end up getting a final answer of root 80 equals t. And like realistically, I'd be happy with that. So on a test, that's what you'll see. You might have to change it into a decimal, so you might have to actually calculate what it is into decimal. However, this question had a little bit of a trick to it, which is like a throwback to Unit 1. It said simplest radical form. So remember, simplest radical form would be something called a mixed radical, where you get a coefficient out front. It's been a long time since we've done that. What you would have to do is find what number divides into 80, and I think 16 divides into 80. 16, the square root of 16 turns into 4, and 80 divided by 16 is 5. That's the technical final answer. You won't have to do that on a test. And maybe a final exam, probably not, but not on a unit test. That's what makes this question a little bit harder. So throw back to Unit 1. Long time ago. Fantastic. That's the algebra behind function notation. We're going to do one more question from the next lesson, which is going to be how to use function notation on a graph. Okay, because that changes slightly, but really not much. It's actually easier, I think. So if you keep going, we're going to flip the page a couple times here. I think it's example 3. Yeah, for sure. So we have it right here. We're going to switch all the way down to press example 3. Page 472. This is the only example we're going to do from here. We're just going to look at how you use function notation with a graph. Okay, so the graph of function f is shown. Here's a graph, right? And if you got given an equation, remember you could put that graph in your calculator if you wanted to. Then they ask a whole bunch of questions. The first question says, complete f of 5. What does that mean? It should be giving you an input or an output. Is this giving me an input or an output? Input, right? They've changed the inside number. What they're telling you is that x equals 5. What they're asking you is what is the y value when x equals 5. So you need to come over to your graph, find where x equals 5, right here, and then move up or down until you hit your graph. When I move straight down from that point, I get here. That's where x equals 5 on the graph f. They want to know what's the output. The y value would be negative 2. The answer is negative 2. So as long as you remember, function notation is a way of giving inputs and outputs, you can apply that input to a graph pretty easy. This thing's drawing you one another over. The next one says, what's f of negative 2? That's them telling you x equals negative 2. Looking at your graph, x equals negative 2 here. That red line I've drawn. Your job is to move up or down now until you hit the graph. In our case, we're going to have to move up. And we hit the graph here. The y value would be 1, 2, 3. So the output is 3 when the input is negative 2. I'll give you about 10 seconds to try the next one. So this is an f of 4. So see if you can find the output when the input equals 4. Okay, so I look at this question. This means x equals 4. On my graph, I went over and I made a little line at x equals 4, and I moved up or down from that line. I had to move down to this point. Now I'm on the graph, and I figure out the y value at that point. The y value is negative 1. So the output was negative 1 when the input equaled 4. We're going to try C now. So what we're going to do. C is giving you outputs instead of inputs. Right? They've switched where they're putting their number. Their number is no longer inside the brackets on function notation. It's outside the brackets. So when you see something like this, they're asking you to do y equals negative 1. Really doesn't like my board today. Looking at your graph, where does y equal negative 1? It equals negative 1 right there. Anywhere on this line left or right. So if I go to the right, I'll eventually hit my graph right there. Your job is to figure out what the input value is, the x value. The input value would be positive 4. So for this question, the answer would be x equals 4. For B, when they write it like this, f of x equals 3, they're telling you that y equals 3. So you should look up on your graph, figure out where y equals 3. Right there. And move left or right to figure out your input values. In this case, there's 2 input values that would give you an output value of positive 3. One of them is right here. One of them is right here. This question is going to have 2 answers. It's going to have x could equal positive 2 or negative 2. That means 2 different inputs could give you that output. The last one, f of x equals 4. That means you would go up to where f of x equals 4. That's where y equals 4. That's right here. The 2 different points are there and there. That means x equals positive 1 and negative 1. Function notation is just a way of writing inputs and outputs. When it comes to a graph, inputs are x, outputs are y. So as long as you can remember which one they're telling you, you'll be able to figure out the one that you want. And sometimes that's not easy, right? Like to be like, oh, what did they tell me? But they're always going to give you either X or Y, one or the other. And you're always finding the other one. So if you can figure what they told you, it'll make your life way easier. And as math progresses, we do a lot more algebra. If you can figure out what you know, it makes it a heck of a lot easier to figure out what you're looking for. Okay, so that's my advice. I think that's all I wanted to do. I don't think I like any of these other examples. Yeah, no, we're good. So I'm going to hand